Right folks, well, if you think it's a bit dingy in here, so do I, because the fluorescent bench light has failed, and I've got a new tube on order for it. It's an 11 watt dual lux thing. Now there are 4 ceiling mounted fluorescents in here, so there's plenty of light in the room, but not for things like soldering, so I may nip to other benches elsewhere. Right, we've got an Audioline 342 which was kindly sent in by a viewer. Just put these brackets away from yesterday's Uniden 100. So we're looking at this Audioline 342. I've got the service sheet out. Hello. That was an avalanche. So these were a lot of money at the time, and they can be troublesome. We've got one with a duff cable. There's absolutely nothing I can do about it. So you've got the remote set which goes in the boot. You've got a very swish looking handset. Unlike the binatone breaker phone, it uses the Sanyo chipset, which enables serial data to be going up and down the cable, rather than with like the realistic used conventional number of like 8 wires going down the cable to do the channel change and display. This uses serial data, so you've got an added possibility of trouble. Is it the LC7? So the synthesizer's LC7137, and it's LC7191. Is it? It's the scan generator. We really don't need to know all this. I think I'm just telling you stuff for telling you sake. I really don't. LC7191 is the data chip in the handset, and LC7181 is the data chip at the other end in the body of the radio. So those two communicate via serial data. I did have a car that I couldn't use one of these in because the car's computer, and we're going back to 1980s, it interfered with the radio. They can have a troublesome whine. I'm just telling you all these pitfalls. They were £149. You could buy an extension cable at the time for a lot of money. And you could also buy a relay box, which when the squelch opened, would switch your car radio to mute or something. So got that versatility, but a lot of money. But a very good quality connector, and all we have to do is put it in the right way round. Just like that. Now this looks in good condition, and I've seen some with corrosion. I mean, they're 40 years old. I did once get one brand new for £19.99 from a catalogue clearance shop. The mail order catalogues like Grattan's and Littlewoods and all that kind of thing were doing these at the time, and there was a shop in well, the one in Lincoln, and the one I'm thinking of was actually in Rotherham, and I bought one brand new, and it was £19.99. Kind of sad, isn't it? Okay, so we'll switch it on in the dinginess of my bench. And on this one, the controls aren't noisy. Got high-low power, tone high and low, and channel lock, so you're not going to accidentally do that. PTT's there. I mean, to have up down in 1981 was incredible because everything had a rotary channel selector switch. Right, so we'll go through the parameters. And I'll put the squelch on. So these have troublesome capacitors, just like other Uniden products. So we'll put picture-in-picture on. And we're on the main meter, we're on channel 20. Let's key it up on the low power. I'll tell you what we'll do, we'll connect the equipment to the aero socket, that would also help. At the same time I'll connect the test equipment to the radio, to the aerial, through the extension speaker socket there. It's just doing above 3 watts. .9 on channel 40, 3.1 on channel 1. Back to channel 20. Low power. It's doing 350 milliwatts. And back to full power. And the radio's doing 929 milliamps. And bear in mind, you haven't got a meter bulb, have you, to light up? And this was also nifty for the time. The red LED, it's a dual colour LED, which was pretty well state of the art. Deviation we won't be able to read on here properly because it's playing up, isn't it? Well, it's about 1.5 on this one, but we'll do that properly on the test set behind. We won't be doing the VCO, it's not necessary. And what is the frequency? And it is 2779108. So with that, we'll put the signal generator to the same frequency, 2779. I had an email saying the fluorescent tube for the bench light was arriving yesterday. But you usually have to add 1 to 3 days to what they tell you. 108, wasn't it? Just drop that a fraction so we're being fair. Right. So we'll have a look at the SINAD meter and see what it's got to say. Pop the squelch down. These are crystal filtered as factory standard. 0.35. 0.3 and 0.95. Squelch to 4. Put the attenuator up on here. Let's just see where. That's 100 microvolts. That's 3 millivolts is tight, which is too tight. Let's go back to minimum squelch. Signal generator to standby. Set the squelch on the radio. Oh, that's not good at all. 2.5. So it doesn't have one of those. It doesn't have one of those. It doesn't have one of those. They're all right. Doesn't have one of those. We'll pass judgment in a bit on those. The squelch could be dodgy. that works, and that works, and that works. So we've got the Trader Service Manual, Trader 4038 from February 1983, which was available to the trade. So 0.7 microvolts for 20 dB, it's already beating that. 4 watts maximum. Always read something into that, because if you say, well, it's only doing 3.1 watts, well, that says 4 watts maximum. It doesn't say that every sample will do it. Let's see how to dismantle the thingy, where the thingy is, where all the alignment points are. It says adjust for 3.7 watts, but if it'll do 4 watts, we'll do that. 4 watts. So we know it's kind of working. It's, you know, if this was being sold on eBay, it is in working order. I have ordered some of these bright BZP screws, but I can't get the Japanese spec ones with the dot. I looked on AliExpress in the hope that stuff coming from the Far East probably had the right spec, but not so. So that's in really nice condition. Oh, it's been recapped. It's already been done. Yes, the two 220s and the two 470s have been changed. So very similar circuit electrically to the Uniden 100 we did yesterday, and also of course that applies to the Uniden 200, the Audioline 340, 341 and Realistic 2000 and 2001. So yeah, that's a job done. I'll check underneath, seeing as it's been done, to make sure that it's acceptably clean. I wouldn't be surprised if the person who kindly sent this as a gift also did the recap. I'll go over that with isopropyl. Right. So we're not going to touch the VCO because it's working on all 40 channels and it's never been disturbed. So I think our lineup's going to be that, and that, and up that side. So I'll just check with the service manual. Transmitter. They say what? Could be 918. It doesn't look. It doesn't say L8 there, does it? Oh, it does. Yeah, it's L8's the receive one. So it's 9. L18 and then L10. Why isn't 10 shown? Okay. So here goes, we're going to transmit on channel 20. Just make sure this is on the main meter. So we have dropped slightly. Got a dry joint on here. I'll get Mr. Chippy onto that. I've only just switched the soldering iron on like a wally. Change scales. Now I am struggling with that. We'll have to do the dry joints before having a successful tune-up. So I'll do the receive. So the receive is going to be down 2, 3, 4. Detector. No, detector's going to be there. 2 AFs. I can't speak. Are going to be there. Doesn't have a crystal filter on this one. Am I muddling this up with the realistic 2003, which does? So forget that about me saying about crystal filter. This does not have one. So you didn't get that for your £149. Okay, receive. So we'll start off by going to the oscilloscope. Put 100 microvolts on, doing the detector. Just put enough volume for it to be sensible trace. That's a long way out, which will also be the reason behind the squelch being far from ideal. Over to the SINAD meter. And drop the volume of fraction. Drop it a bit more. Worse. Now that was at peak. That was also at peak. Tiniest little bit there. I'm going to do that one while we're at it. That's fine. Now we'll put a bit more signal on. Do the intermediate frequencies, the IFs. Bit there. That was spot on. I don't think we're going to have much difference from where we got. Let's see what it now says. But the detector will have affected the readings. We've now got 0.29. And then for 10 dB, 0.25. And for 20 dB, 0.9. Just turn the volume down a fraction. Let's just see where the squelch is. VR1 appears to be squelch. It's 3. That's 2. And the one not shown, oh, it is shown, it's me who can't see it. The dirty looking one, I'll just get the fiberglass brush on the real silver wiper just so you can see it better. That's better. So make sure squelch is at full. So we can't open it quite where I want it, but not far out. It's 300 microvolts for maximum squelch. Now we'll drop the squelch on the radio, put the signal generator to standby, put the squelch to threshold on the radio, put the signal generator back on. You know what, it's still lousy. Let's try that again. No, it isn't any better. I'm going to have to look into that. I'll have a look and we'll get back on the video. But I'll go through this for dry joints anyway. I'll get Mr. Chippy to do so. So we're heading in the right direction. Right, folks. So Mr. Chippy's been over this for dry joints using the video microscope. And he's also gone over it with I can't even speak. Isopropyl alcohol. Good. Right, I'll get back to channel 20. And we'll carry on with the transmitter. .2-ish. You know, while the soldering iron warms up, because I've forgotten about that again, I'll do the deviation. I'll on the test set behind me. So I'll get it connected to that, which is a Quartlox 282A. Wow, it's a bit high, it's about 2.8. We'll deal with that, which is the preset. Well, VR3 is low power, so it must be VR2 there. Wallow. Right, that's that done. So it wasn't far out, but it was loud enough to be troublesome on well-filtered receivers. Right, so get that noted, that it was 2.7 kilohertz. It's now 2.2 to a peak of 2.5 kilohertz. Let's see where we are with frequency. Now the test gear's been on for an hour. Let's put the $27,79124. Wow. Won't be touching that then. Keep wanting to put my bench light on. So once again, there's no trimmer for the frequency, so luckily it's spot on. Right, back to where we were with transmit. I'll put that onto the correct meter so you can actually see what we're doing. That is peak. Ooh, we're not quite there. It's supposed to do 2.7. 2.9, sorry, it's supposed to do 3.7 and it's doing 3.9, so it's above what the manufacturer says it'll do. Just going to check the placement of these coils. It's so close. When this is cold, it's definitely doing 4 watts. .95 is what we managed. Channel 40. 3.8, channel 1, 3.95. I might just see whether we can get a slightly better balance. Not with those, I won't. That's channel 1. No. Go back to channel 20. So close to 4 on channel 20. Anyway, it's doing more than what the service manual says, and it says 3.7 watts there in black and white. So on channel 20 the current consumption is now 1.116, and low power we will now adjust. And we have 400 milliwatts. Since Mr. Chippy's done the dry joints, absolutely stable. Right, so we're still one more thing which I'm not happy with, which is squelch. Maybe nothing I can do about it. Don't think it's got squelch sensitivity. So they're saying better than 0.7 microvolts for 20 dB. Well, it isn't. That doesn't mention squelch sensitivity. Just take the picture-in-picture off. Take the signal generator off. Set squelch. Signal generator back on. No, it just isn't good enough. I'm going to have to go. I'm going to go through these IFs. I might use a different technique. Except I've got my other signal generator across at the chapel. We were doing a demonstration for the radio club on Saturday. But I'm just going to go through these ones again. Just start with the 100. And put picture-in-picture back on. Show the oscilloscope. Make sure they're sealed. A bit more volume. I'm going to unset these two. Reset these two. Unset that one. Recheck the squelch. That's it, we've corrected it. I'll be a bit more casual now how I set the squelch. Yeah, really casually setting the squelch, and it's 1.5 microvolts, which is slightly too high. So I'll be carefully set up to turn the signal chain. Carefully set the squelch. I can get 0.3 coming in. Yeah, we'll give it one. We'll say 1 microvolt. And the maximum squelch is now 100 microvolts, which is exactly where I want it. So you saw I untuned and found a definite peak on each of those, and then I returned that one to its correct position, and then we matched it up with the other. So looks like the IF was out and didn't respond to the normal treatment. Right, put the lid on that. Just key up now, because it's been not transmitting for a few minutes. Go back to the power meter. 4 watts is there. It is 4 watts when it's cold. So whoever did the capacitors, good job done there. And it is important that if you see one of those, if you see one of these sets, that you change those 4 capacitors. We always put 105-degree ones in, and we always up the voltage slightly, because you know some of those are 10 volt working, and that may be fine, but you know, you may as well put 16 or 25 volts in for the tiny cost extra. Rule of thumb: never exceed 10 times the actual voltage. So, I mean, I'm probably talking valve type stuff here, but supposing you came up to a circuit, well, we could say this is, for the sake of argument, we could say this is a scenario where you haven't actually got the right capacitor in stock, and you come up to a circuit and you know that it works at 10 volts, and the manufacturer has put a 10 volt electrolytic in, and you haven't got one. Well, you can put up to 100 in. Now, if you exceed the 100, what's going to happen is it will lose its charge. So you've probably heard other people talk about reforming capacitors, especially on valve television sets that haven't seen the light of day for 40 years. And you're putting a charge back, as the manufacturer had originally done. You're putting a charge back on the capacitor, so it's kind of giving its identity back, which is positive and which is negative. And you've got to do that in a controlled way. Are you going to be in danger of, if you suddenly put 30 volts across a 30 volt capacitor that's been dormant for donkey's years, it's not going to be able to cope with that, and it's going to end up puncturing a hole in the insulation internally, and then you end up with it getting hot and blowing up. So the idea is to slowly reform the capacitor. Michael Dramfield's got a thing for that. We're going to be building one based on the same circuit, but much less sophisticated than what Michael Dramfield's done at Buxton there. So it is something that needs doing, and it's Paul Stenning who is the person behind the design of these things. And when he was doing his trader service sheet CD-ROMs, I worked with him to provide some of the ones he hadn't got, because I've got every trader sheet ever going, and of course we're working from a trader service sheet, so my collection goes back to about 1934. So Paul Stenning's the man with the knowledge on that. Right, well, we'll switch off and I will go over to the aerial. Well, let's see who's playing music on 19. One Anna Roger. Let's go to its own speaker. Right, well, there we have it. The Audioline 342, a very expensive set at the time, and potentially quite a troublesome one. Most of the other snags, apart from those capacitors, I've had failures in here, and apart from these controls getting nicotine in them, and if it's been in a fag smoking household and becoming troublesome, you've got the problem with the lead, which is about 16 cores. I've actually had the lead that's failed is that it's actually the braid that's broken. Unbelievable, but it's happened. What else? That I've twice had the scan generator chip fail. Somebody in the burner brigade's on the on the verge of squelch there. Right, so we'll do an on-the-air test of this. Thank you to the person who kindly donated it to the channel, and I hope it's of benefit to people you know, seeing how these are tuned. We do have this if anybody needs the trader service sheet. This is a scan that I did of the original, and I can email that through to people as a PDF attachment. Thanks for watching.